Okay, last problem, number 6 on our homework. We've got a beam with an angled force coming down 30 degrees from horizontal at 500 pounds. We'll call that, looks like in the problem, that's P2, or I'll call it F2, and F1 is coming straight down at 350 degrees, and we've got our distances there. So since we're following the trend we've been doing before, I'm going to slide my calculator over here again. Why don't we break that force 2 down. So we'll say F2x, and we'll say that again, our x forces just in general, if you've noticed the pattern, is going to be our cosine. So we're going to say 500 cosine 30. And so we'll type 30 cosine times 500, and that'll be our 433 point, just 433 pounds. Okay, and then we'll write here F2y. I guess we could say that's a negative 433 since it would be acting to the left, down and to the left. It'll be 500 sine of 30. Well, if you also remember, sine of 30 is 1/2. We've been doing this enough now. Sine of 30 is 1/2 times 500 is going to give us 250 pounds. Okay, so there's our initial forces broken down, and that'll help us make our free body diagram a little bit faster. So our next step is our free body diagram. And we will do this, and we've got FAX, and we've got 433 pounds acting left. For our y forces, let's just start there. We've got 250 pounds acting down. We've got 350 pounds acting there. We've got FBY acting at the end. And we've got, darn calculator, I'm sorry guys. FBY acting there, and we've got FAY acting there. Okay, so that's our first step, is figure out our forces and break it all down, and then we can have our moments or equations of equilibrium. So, and again, this free body diagram system here, you could just redraw that force with the angle, and then you'd be doing your calculations just using this. But this is the first time I've done this, but I kind of like breaking it down this way because it just keeps things a little cleaner and a little easier to see. So I hope you guys like that too. So we got some of our forces in x are equal to 0, and that's FAX minus 433. So we'll say FAX is equal to 433 pounds. That's nice. And we can do our y forces. Always just same pattern over and over, same process. FAY plus FBY minus 250 minus 350. Those are all of our forces that are acting in the y direction. Once again, not enough information to solve, so I go to my moments. So I have moments are forces that are acting away from point A, or forces acting at a distance away from point A. So again, FBY is going to be my positive moment, and that'll be times 20 minus 250 times 13 minus 350 times 19. Okay, so FBY times 20 is going to be equal to, I'll just, again, move these from side to side. So if this is 0 over here, all of this part would get added over here. So I'd have 250 times 13 plus 350 times 19. If I type that in quick, that's 3250 plus 350 times 19, 6650. So if I add those two together, 6650 plus 3250 equals 9900. I take that divided by 20, divided by 20. Getting off my page here. FBY is equal to divided by 20. 9,900 divided by 20 is equal to 495 pounds. There we go. So then I take that now and plug it in back up here, and problem solved, literally. So I'll take, if I were to do this, I would have FAY is equal to 350 plus 250 minus 495, because this all would move to the side of the equation that has 0 on it. And if I move my calculator so we can see a little bit easier, 350 plus 250 minus 495. There we go. FAY equals 105 pounds. So as you can see through all these examples, the process is always the same. What are your forces? Do you have any angled forces? If so, we got to break those into X and Y, and then it's just plugging everything into the equations of equilibrium. So I hope all these problems helped, and good luck.